I will plug in just to make sure. Negative 3 times 1 is negative 3 plus 1 is negative 2. Negative 2 over 2 is indeed that. So then I will write the definition, which you use symbols or not, it's fine by me, but you have to write a definition. For every epsilon positive, there exists a delta positive such that every time I pick x close to 1, this will always imply that the function 1 minus 3x over 2 minus negative 1, which is positive 1, is less than epsilon. So this is what I have to write first thing. Then I start here and hope to get that. So I'll find the least common denominator. 1 minus 3x plus 2 less than epsilon. And that reminds me, we know that delta is a positive number. When we had this homework, the written homework, a lot of you found that delta equals negative 3 epsilon over 5 or 4 or whatever. But is it possible? We already said that delta has to be positive. How can I get a negative number for delta? So please be very careful. Okay, so then this is 3 minus 3x over 2 less than epsilon. I'm hoping that you're going to go and learn from your mistakes by comparing to the solutions. Because then otherwise you're not going to present your work correctly for full credit, please. Okay, at this point in time, I will have to factor out negative 3 inside. Then I will separate the absolute value of negative 3, the absolute value of x minus 1 over the absolute value of 2. This is a mandatory step. Do not assume that you can multiply both sides by 2 and divide. Do not. That's how you got a delta which is negative. Okay, the absolute value of negative 3 is 3, then x minus 1, and this is 2, and less than epsilon. We multiply both sides by 2/3 to get the absolute value of x minus 1 less than 2 epsilon over 3. And this must be our delta. And in step 2, all I want you to write is reverse the steps. Reverse the steps from part A for part 1, showing that delta to show that delta equals to epsilon over 3 works. This is necessary because of this symbol. Otherwise, it would be not necessary. But because of this symbol, we have to show, or at least show that we know that 2 steps are required. One from left to right, one from right to left. And if you get a delta negative, something is terribly wrong somewhere. Good. Anything else? Anything else you would like to go back to?
Actually, could you continue the problem when you say reverse the steps to show the delta?
You don't have to do anything, but just write this sentence.
Okay, got it.
Yes?
Answer the last question we did.
Yes.
The one before this.
Yes.
Yeah, this one. Which chapter is this?
Chapter 2.
Chapter 2 point.
The intermediate value theorem?
Yes.
I think the intermediate value theorem is under continuity. So the continuity is at 2.5. Good. Anything else? And it's a very good question. I did not show that, but the reversing, you will write this, and then 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 you will write this. That's exactly. I don't want you to have to copy these steps again from the first one or from the first one to the last one. There is no need. They're already there. Anything else? Is there a particular type of problem that you say, well, if I see it on the test, I may have some difficulties with it? Any? Or any problem that you simply would like to see again?
Could we go for number 6 on the practice test?
Very good. Let's take a look.
Wait, no, we already did this one. That's my bad.
You said number 6, I think you said. We did that.
Yeah, that was my bad. Sorry.
No worries. Anything else?
I'm looking for one.
I'm sorry?
I'm looking for one right now.
You said you're looking for a problem?
Yeah, because I know I had one in the other side.
Good, good. In the meantime, anyone else?
7. I don't think you did number 7, right?
This one?
Yeah.
Okay. Let me see if I can just print this page out. And that was which page? And that's page 5. Um, five. Because it would be easier for me to explain. If it takes too long for it to print, then I will just grab it on paper. I think it's going to print. Wake up, wake up, wake up. Wake up. Let's try again one more time. 5. Can you please print page 5? Yes, no, maybe? Oh, of course not, because it's not hooked up right here. That's why it's not printing. Now it's going to print twice. Okay. Thank you for printing twice. Okay. So for the following function, do not graph its derivative, but find the intervals on which the derivative is negative, positive, and 0. Okay. So first of all, we know that the derivative is 0 at every peak or valley. So here at the top, the derivative or the slope is 0. Here is 0. So I will identify 5 and I will identify 15.
Switch your page then.
Oh, yes, of course. Thank you. Sorry. Okay, so let me start from scratch. Oh, see how good that I have 2. So first of all, I'll start with 0, where the slope
I think your
is.
camera's out.
What else is new? Because I touched the hub, that's why. Okay, so 0 right here. and here. So at 5, so the slope is 0 at x equals 5. The slope is 0 at x equals 15. And then,
You can see that it looks a little blurry.
yes, it does, because, but I'm sure you're gonna be able to see this when I post it.
Okay.
So this is 15. Just look at the test, right? So where it says 5, right? The slope is 0. At 15, the slope is 0. Is that okay?
Yeah.
Okay. And of course, where is the slope positive? Positive, 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 positive. So when the function is increasing, the slope will always be positive between 0 and 5. So the slope is positive, which is the derivative, for x between 0 and 5, union 15 and 20. And of course it's negative when the function is decreasing. So the slope is negative between 5 and 15, for x between 5 and 15. And I will post this. Good. Anything else?
I sent one to you.
Yes, I'm ready.
It's a screenshot.
Oh, yeah.
It's a screenshot.
Good. So I'm going to get it in the chat then. Oh, you already
Yes,
sent it.
yes.
Okay, perfect. Yes. Good. Almost there. I'm clicking. Downloads. Okay. For some reason, it did not download it. Okay, let me try again. Huh. I lost you guys with all these opened. Okay, got it. So let me try one more time. Ah, here it is. Good. Got it. Okay, just continue to evaluate this limit. Well, in this particular case, I'm just going to copy it. So this limit as x approaches 3 from arc tangent x squared minus 9 over 3 x squared minus 9x. Okay, perfect. So first of all, I see that the numerator goes to, so this piece goes to 0, and this piece is 3 times 9, and 9 times 3, so this goes to 0 as well. I cannot make a conclusion because it's 0 over 0 inside arctangent. So first I have to simplify this as much as possible. When I replace the x by 3 and I get 0, top and bottom, what does that tell us immediately?
Oh. Yeah, this one.
What does that tell us? By the remainder and factor theorems. When I plugged in 3 and I got 0 in a polynomial, forget about this for a moment. In a polynomial, yes? When we plug in a number in a polynomial and we get 0, what does that mean? It means that x minus 3 is a factor in both of them. So by the remainder and factor theorem, when I plug in 3 in a polynomial, it means that, and get 0, it means that x minus this number is a factor. So the top has another factor, which is x plus 3, by the formula we reviewed on the first day of classes. Here I also have a 3x, right? So this is times 3x. So when we factor out 3x, then you get x minus 3. At this point, I'm allowed to simplify. I simplify the factor of x minus 3. I don't have to write x not equal 3 because this means x not equal 3 by definition. So now, what is left? So I have the limit as x approaches 3 from arc tangent x plus 3 divided by 3x. Like before, I will factor out x. Limit as x approaches 3, arc tangent, the degree is x, and the degree is x, but I don't have to do anything to the denominator. Can anyone tell us what we write inside parentheses?
1 plus 3 over x.
Yes, awesome. 1 plus 3 over x. X times 1 is x, x times 3 over x is 3. Perfect. So then we simplify exactly what we wanted. Okay, it wasn't really necessary. I'm sorry, I got carried away because this is not infinity. So this step is not necessary. So 3 plus 3 is 6. 3 times 3 is 9. So this is arctangent of 6 divided by 9. But 6 divided by 9 is the same to arctangent of simplified by 3 2/3. There is no need here. It's not a mistake. But there is no need because this is not infinity. We do that only when it's infinity. So I'm going to cross it out. You'll get the same answer, but there is no need for this. We already removed the problem. The problem was 0 over 0, and we removed it. By removing x minus 3, we no longer had a problem. All we have to do is just plug in. So it's 6 over 9. So the answer is arctangent of 6 over 9, but simplified 6 over 9 into 2/3.